Good evening, everybody. Welcome on in. It's Friday night, my friends, and I'm back. And we're going to be jumping into some coding stuff, some game dev, Java game dev things here. I believe we need to start chapter 8, or at least get, into actually loading up complex models and textures. Now we had started to look at some of it as far as like the diff goes. What I need to do between the last chapter and this one. It's a lot of new stuff, but I think one of the main things though is moving our model loader, which I think we started to do. We actually moved the model loader over, and it looks like this should hopefully work for what we're trying to do, which will be really nice. And yeah, texture file. Saying texture file is always null. Right. I think that's the one thing. Process material. Oh, there's a list of texture files, potentially. So I would need to do how do they have it? Yeah, how did they do their load here? They have a textures directory. Oh, they process the entire directory, it looks like. So their process material. Texture path. Get name for that material. Oh, that's right. I was passing the list of texture files in order to facilitate whatchamacallit? Yeah, loading up my own textures outside of the model itself. So that would be so I wonder how I would I guess I would assume that it's Yeah, I'm not quite sure how that's going to work for our purposes, because I need to actually load the texture file in, because the texture file for the model that I want to use is separate from the actual model file. Like I don't think the model file even has the texture name in it. I mean, it might. We'll have to see. Because it might be just a matter. It might be just a matter of like it might just have the texture file name. It might be just a matter of leaving that file name the way it is, potentially. I mean, let's see. Yeah, we'll just run through it. I mean, worst case scenario, it'll just be like the model file doesn't exist or whatever, or the texture files don't exist. Whatever the case may be. Anyway, so we have the model loader here into common, and then I think is it chapter 7 to chapter 8. Compare those. I don't know why that's why it doesn't save the directories correctly. So chapter 7 to chapter 8. Okay. Some shader stuff to do, obviously. So I can start with like descriptor pool and stuff, but I think we'll look at the book and see what it starts with here. So what are they going to start with? Model generator. All to be transformed. Oh, okay. I see what they're doing. They're generating model files. So I think that's just so that they can have a model file to use. Okay. Process material. What are they doing? Okay. Model generator. Hey, Anarchy. Welcome on in. How you doing? It's going good for me. It's going good. Just trying to learn some game dev programming stuff. Mesh data, model bin data. Model generator. And then they've got their model loader. Generator. Utility class to load and deserialize pre-process. How long have I been coding for? So professionally, I've been coding for just over 20 years. But I do full stack web development, so programming websites and stuff like that. The back end and the front end of websites. That's primarily what I do. The game dev stuff here is just new for me. It's something I just kind of wanted to do on the side and just kind of learn how to write an engine and all that stuff. And so yeah, I've just been kind of diving into this over the last couple of months. Just trying to see what it's all about. I don't necessarily have a game endpoint. I don't have a game I'm necessarily driving towards, but I'm more like trying to just learn by doing. So yeah, that's where I'm at. And I do pretty much mostly Java code, and that's what I'm doing here too, just so I can stick to something I know pretty well and just kind of focus on the things that are the concepts that are different for this. So did they have I'm confused here. Did they put a model generator and stuff in here? They have a model data. And a model loader. Yeah, okay. Which is what I would expect. So what are they doing? Where did they get this model generator from? I think that's just something they did on the side so they could generate the object file. Because I don't even see the code for it. Oh, weird. We got the right thing, right? Graph. Huh. Dabbled in high school back in the day, not currently, so enjoy watching others. Yeah, it's I enjoy coding. It's a little bit difficult to stream it because it's not the most invigorating thing ever, unless you're doing unless you've got a lot of visual stuff going on. And right now it's mostly just me going through code and eventually getting something on the screen. It just takes a while. And what makes it a little bit harder too is like I've had a full day of work of just doing code, and now I'm doing more code. So my brain is by this point usually running on fumes. Yeah, it looks like they just put that here. This model generator stuff just to show how they generate it, but then they didn't put the code out there. Unless I'm really, really blind here. Let me see. Model loader. Yeah, it doesn't look like it. Because it wouldn't be necessary for the testing stuff. It would just be kind of a side thing. Yeah, weird. Alright, whatever. So I can ignore probably most of that for now, hopefully. Although it's generating JSON files. I don't know why it's generating JSON files. We'll use the JCommander library to parse command line options and JSON to generate JSON files. Yeah, definitely burn candle both ends. But I'm having fun doing this, and I'm doing stuff that I want to do instead of stuff that I'm getting paid to do. So that helps. JCommander, yeah, okay. Transform models using into an intermediate format which will be ready to be loaded into the GPU. We will create a class that lives. Why? And dump the results to a JSON file. It's a little bit overkill for a tutorial like this, but will prevent you from processing models again and again. Okay. Prevent you from processing models again and again and will simplify the loading process at the end. I beg to differ on that. I mean, you just load the model into memory and then you'll just have to load it again if it falls out of memory. Like, or better yet, instead of doing any of this stuff, if you really want to write, like, you're going to load the model into an object and then make that object serializable and then just serialize the object to a cache or even have like cache or something in there that will write cached items to disk for you and manage the cache for you, like evicting stuff from the cache and bringing it back in and then just call it a day. Like, why would you go through all this nonsense to do something you could just grab something off the shelf to do? Like, I don't. It's so weird. I'm not going to do that right now because it's easy to implement a caching thing later. Almost like, dare I say, trivial. And then like none of this is needed. Like, it's so weird. It's like, yeah, we'll take these object files that have models in them and we'll convert them to JSON and write them to disk to temporary file. So we don't have to process it again, but we still have to process the JSON every time, which theoretically is faster, but I mean, you still got to process it when the model goes out of memory. And right now we're just putting one model in memory. It's not like we're doing an entire scene yet. So like, what is the freaking point here? Like, this is probably the most, like, up to this point, the book's been really, really good and it's made sense. This is the first time the book is just kind of going off on a weird tangent. Weird, unnecessary tangent. And I suspect someone figured that out because none of this code is actually in their repository. It's only on this page. So, yeah. Going to skip that part. Model generator. Okay, so now we're into model loader. Fine. Textures. STB. I think I have all that loaded already. do I have LWJGL STV loaded here? I do. Okay. I figured I did. It's just a record to hold the decoded image data, its width and height, and number of channels. Alright, so image. So called graph utils. Methods to load texture from disk using STB library and to free resources. Okay. STBI load to load an image from disk. The function receives a parameter for image file. Right, so I already have this stuff for the OpenGL portion of the engine. So I just gotta find that. I thought I had. I guess I don't have it in the load here, right? Or do I? Process texture coordinates. Get texture path. No, so I just have to get the texture paths and stuff. So the actual texture processing we got up here, I think. Yeah, here's the load texture and generate texture. So this I couldn't pull over because it's got OpenGL stuff here. So, alright, so that's why we left that alone. Now, that being said, my guess is I could take this load texture method as is, and then all we need is to okay. So I can take this, I can promote this to a base texture class, put the base texture class in common, and then have an implementation of it for OpenGL and the other one where it implements the generate, bind, and cleanup. Right, and then yeah, I guess the get path, get ID. I wonder what else they have put in there. So looking at texture. Of course, I got the device in there, all this other stuff, which is just okay. So clean up, get image view, record, copy buffer. So we got a common cleanup at least. Okay, so here's what we'll do. What I'm going to do is I'm going to take this method. I'm going to have to make it, See, it takes path directly, and does it take ID? No, ID is down here. Okay, so what I'll do is I'll have it take path as a parameter. And then that way it doesn't have to hold anything. So I'll copy that. We'll come over to here and I'll say new Java class base texture. And I think I want to make this abstract. Okay, so paste this in. Let's see what I've got here. We'll do string path. So make that happy. We'll do private static final logger factory. There we go. So we can log things. Make this protected. And let's see. The generate texture is private, right? So I'll make that protected. And we'll say protected abstract generate texture, and it takes width, height, and buffer. Int width, int height, byte buffer. Okay. I did something wrong here. Oh wait. That's what I did wrong. But what does that take anything back? No, it doesn't. Okay. Do they have a generate texture over here? Not really. But what is generate texture doing over on my, so it's doing generate bitmap, all that stuff. So where do they generate their bitmaps and things? Image data with height. So what's image? Image is STB image? No, let me see what it says over here. So we're looking at texture. What's image? Okay, so that's Vulkan. So that can go. So is image. Well, image is something we've created, right? Yeah, okay. Image is a method that we've created on the Vulkan side of things. So they have file name, image format, device, which is fine. I wonder if it even makes any sense to even do this. because this is, so we do an STBI load here, and what did I do? Channels, okay, desired channels 4. Alright. So that's all the same. Lift height, MIP levels. So I don't have the MIP levels here, but I mean that seems fairly universal. I'm kind of wondering if it's even worth sharing that one little load thing. There's a hell of a lot more stuff you have to do with Vulkan than you do with OpenGL. Like this is literally all the open, like 65 lines of code for OpenGL, and then the Vulkan stuff is 164 for the same damn thing. All right, let's think. I would like to reuse this, especially with the image free stuff, because where do they do their image free? Down there. Okay. What is this, auto closing? No, doesn't look like it. I should have this in finally. Okay. Yeah, I kind of, so the thing is the generate texture, like what do I do there? Because that's got to be, that has to be different. What does it actually need? It needs a width, it needs a height. It needs the MIP levels. And the rest it creates. It needs a device, but we can set the device, we're setting the device in the constructor. And the image format is in the constructor as well. And we're passing the file name to it, if I'm not mistaken. Or we will be. Yeah, we're passing the path to it. So then, which is really not the path, it's really the file name. Yeah, file name. STVI load file name. Yeah, so let me fix that. So file name. It's Alt-Shift-R. Okay. There we go. Okay. So, and then what is buffer? That's the actual image itself. Okay, so what do they do? They have a byte buffer. Okay, so they just pass that in there as well. Okay, so the generate image for them also requires a width, a height, a buffer, MIP levels, and that's it. So all I have to really add here is MIP levels. Right, and then we'll do that here. Good. So then this goes into finally. They really want me to initialize it, huh? Oh, they just set it to null. That's fine. So then okay. Do we need channels for anything? Where do I use channels at? They load up channels. They don't use it yet. Okay. Alright, that's fine. Alright. So with that, with base texture then, and then I need I need a cleanup, right? And then everything else is just gravy. Yeah, alright, so public void cleanup. Alright, so we'll just do public abstract void cleanup. Alright, so now if I come over to texture here and I say that you are, first of all, let's refactor this and call it geo texture. Rename variables. This is OpenGL texture, OpenGL texture. No, I don't need to. They're just local variables, right? Yeah, I don't need to change those. They can stay the same. As long as it changed here. And then this is going to be, does this need, I don't think this should be serializable. I have serializable here, but I don't think this is the thing I want to be serializable. Yeah, this doesn't have to be serializable. Let's get rid of that. And then, all right, so then this is extends base texture. Oh no, I have a common model base texture? What? Oh, did I already start? Oh, I already started doing this. Oops. Oopsie. Yeah, I already started doing this. Well, we'll get rid of that one. I didn't even know that I started doing it. There we go. Oops. All right, and then you're gonna go base texture there, and methods, generate texture. Oh, okay, wait a minute. So generate texture, and then this is int mip levels. All right, which I can just set to 1 for now, and then this will be protected. All right, so then I can get rid of load texture here, because that's now implemented by the main thing, and then this just takes a path. Cool. All right, so this is now using the base texture, and then I can now use that to implement the Vulkan texture. So do that here. Asset, new, Java class, Vulkan texture. Do that. Extends base texture. And then implements methods. All right. All right. Logger. Texture class. Okay. Okay. So first thing they have here is all this stuff, which is already taken care of. So width, height, mip levels 1. Right, so the load, oh, I forgot something. So how do I get the, forgot something very important. Oh no, I didn't, because I called width I get, height I get, buffer, mip levels. Okay, so width, height, mip levels, that's called into generate texture. Okay. No, I didn't forget. I'm like, how did I forget that? And it's still, all right. Anyway, so So first of all, so let me get the image data, which I don't even know if I made this. Did I make image data? So where would that be at? Vulkan image. I do have Vulkan image data. Okay. I just pulled it out into its own Pojo, right? Yeah. Yeah, I did. Okay. Okay, so I have that. So... first of all, we need to create buffer here. I don't know what an STG buffer is, but does it actually say here what STG buffer means? Yeah, they have a GraphUtils listed here that has those things in it, and okay, that's not what they have in their actual code here. I don't know. Yeah, image view. Create buffer. All right, here it is. Create STD buffer. Identifier. Image view associated to the image. Image needs to be used by a sampler and a fragment shader, so we need to set this flag. Okay. Image data and Vulkan image texture class creates first a staging. It's staging buffer. Okay, that's what it is. CPU accessible to copy image contents. It also defines the recorded transition. Attribute to control the texture has already been recorded to transition to the final layout or not. This constructor create a Vulkan image. Blah, blah, blah. Okay. Okay, so let's create standard buffer or staging. Standard staging. Create staging buffer. So we have to call that. Ooh, excuse me. Staging buffer. All right. So set that aside for a minute. Let's do public Vulkan texture. Let's make a constructor here, which is what they want. Take the device, file name, and the image format. Okay, that's... What device is that? That's the logical device, not the physical device. Okay. Alright, so... Logical device... what was the other thing? File name and image format. And they do... What else do they have here? Oh, they don't even keep the device around. Okay. I don't need to keep the device around then. So get rid of that. Height. Image view. So height width. Recorded transition. I don't know what that's for. What does this do? Oh, it's okay. It's just a flag to say it was recorded to the staging buffer. Okay. Is that really? Okay. I mean, it's Boolean. I don't really care all that much, but just weird. Oh, they made staging buffer a thing too. So, height image. They don't keep image format around either, do they? Okay. Height image. File name. Height with image. Image view. Image view. Nip levels width. Recorded transition and staging buffer. What kind of buffer is it? Oh, Vulkan buffer. So we set record transition to false immediately, so I'm going to define it as false. Alright. So then we need to... Oh, they're debugging. I'll do some logging. That's not a bad idea. File name. That's when they call the whatchamadoozit. The only thing here though. Yeah, no, that see the image free buffer. Takes place in the finally. And I need that for this to create this buffer. Damn it. So up in the here. Okay. Well, that just means I'm going to have to pass the byte buffer in. Wait a minute. I pass it to generate texture though. I pass it to generate texture, so I can just call that from generate texture. Because then it'll happen in the correct order, and then I don't have buffer all over the place. If equal no, do that. Okay. Yeah, I can just call that from generate texture then. So we'll do, what do they do? So all this stuff will run, and then in generate texture I can, the buffer will be there. I need the device though. I need the device for create staging buffer. So device for me is going to have to be a member variable. And we're going to do this dot device equals device. Yeah. It'll just have to be for my purposes here. So then we'll call generate texture, or sorry, call load texture. That's the file name. That in turn will call generate texture for me. All right, and then that's where, so staging buffer is, what does that take? Device and byte buffer data. Okay. So, which I don't need to give it device because I'll have it. So I just need to give it the byte buffer data. And then what do they do there? Size. Okay, so this dot staging buffer equals new Vulkan buffer. And this dot device, well, I could just say device. Size. Usage type is VK buffer. Usage transfer source bit. Storage. Buffer usage storage. Oh, buffer usage transfer. Buffer usage transfer. Transfer source bit? Is that what it was? Yeah, buffer usage transfer source bit. Okay. The mask VK memory property host visible bit. Okay, VK. Or memory property host visible bit ORed, logical ORed with memory property host coherent bits. Okay. And then, staging buffer map. Okay, so on. Mem byte buffer. That's LWJGL system. Okay. I thought that was a util that they wrote. Okay, byte buffer. And byte buffer. And requested size. Oh, excuse me. Oof. Why would you do a data flip? Oh, flips this buffer. The limit is set to the current position, and the position is set to 0 if after sequence. Invoke this method to prepare for sequence and channel write or relative get operation. Oh, I got it. Okay. Okay. Because it read all the data, so it's positions at the end. So now we're saying go back to the beginning so we can read it again. Okay. I'm doing an unmap. All right. Okay, so first thing we do here is call create staging buffer. What do they have? All right, image data. So Vulkan image data. Format is image format. Wait, did I miss something here? No, I did. All right, well, that just is going to have to go up in here then. All right, and image data. Height to height. Set usage. Oh, VK image usage transfer. Okay. Image usage transfer destination bits board with VK image usage sample bits. Usage sample bit. Okay. NIP levels. It's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And then image, new image, device, image data. Okay. And then what else? Image view data. All right. Just the same stuff as before, right? Oh, format is image get format. I mean, yeah, it's the same thing. Set nip levels to nip levels and then aspect map. VK image aspect color bits. Aspect color bit. Okay, so I set 3 things on that, and they set 3 properties. Right, then image view, device. Okay, so stop image view equals new. Image view, device, what did they put here? Image get ID. Or is it get memory ID? I think it's get image ID, I think is what I called it. And image view data. Make sure here. Hey Tech, welcome on in. How are you doing? It's going good for me. Just about to get to bed soon. Hey, yeah. I hear you. I don't have a whole lot of gas left in the tank either myself right now. Image ID. So allocate image memory. Is that what they? What's their VK image? Yeah, okay, so I picked the right thing. Oops. Okay. Anything yet to show for game? I mean, just a spinning colored cube right now. That's what I have. And that's, I'm in the middle of doing the next chapter, so it's probably not going to compile yet either to even show that right now. But yeah, at the end of this, I'll have an actual textured model. So I'll be back to where I was with OpenGL, where I have the spaceship model spinning. That's my goal for the end of this chapter. And then I think the next chapter they go into like larger scenes and stuff like that. So that'll be kind of nice. So we'll see. So, you know, slow progress, but progress is being made. Okay, so back here, generate texture. So then they were doing. So the image view. Okay, so that's the last thing they did there is set up their image view. All right, and then there's clean up standard buffer or staging buffer. I keep saying standard, but staging. So let's go. Let me see. One day in Godot, messing around, had a character and a coin made to collect and did some fallen blocks of textures of physics. Yeah, the tools are very, very powerful. Very, very powerful, cool tools and all that stuff. Yeah. I mean, that's also why they're popular. You can get a lot done in a very short period of time. I'll see the regular cleanup calls that one. Oh, I got it. Okay. I thought it might. If staging buffer is not null, cleanup. Okay. Here. Cleanup staging buffer. What else? Image view cleanup, image cleanup. Alright. Good stuff. Good stuff all around there. It's got the beginnings of that. So right now I'm just working on loading the textures, which I already had loading code for it from when I did the OpenGL stuff. But I've moved it now into a common area so that both the Vulkan engine and the OpenGL engine can reuse some of it, whatever is possible to be reused. So that'll be good. I mean, at the end of this, the OpenGL engine will be broken just because I have to do even more changes there, but it won't be insurmountable. Ultimately, once I fix that, we'll be almost on par between the Vulkan engine and the OpenGL. The only difference will be on the OpenGL one. I already had keyboard handling done, which I assume is going to be largely probably the same for the Vulkan stuff because it's not really. I mean, well, we'll see. I guess I don't know. I think they have a chapter on input handling, if I'm not mistaken. Let me see. It's the memory allocator, post processing. I have a chapter on GUI, which they're using a GUI that I don't think I'm using or want to use, but that's another story. They do sound with OpenAL, which would be nice. That'll be the first time I've used that OpenAL. Deferred rendering 2, cascade shadows, animations, buffer device address. I don't know what that's for. Indirect drawing, multi-threading. Oh, ray tracing is to be done, to be determined. So I guess I won't learn ray tracing from this. Though that would be kind of interesting. So yeah, I guess they don't do the input stuff here, but that's, I imagine if they didn't cover the input stuff, it's because it doesn't really functionally change between how you do it and, because you use, I think some of it's Joggle, not Joggle, I think there's a common library that you can use in LWJGL that handles the input mappings and stuff. So what I wrote for the one side probably just works on both sides. But we'll see. They might even have it spread into one of the chapters too. Oh, in fact, they're going to have to address it in the next chapter, I think, because there's going to be camera support and stuff. So you're going to be able to move around in a scene, I believe. So they'll probably address it there. Ooh, excuse me. All right. So we're down to texture. Here's what I'm working on. Clean up. And I guess the rest of it's just getters and setters then, right? Oh, well, oh no, we got the record copy buffer and stuff like that. Okay. So where did these are private methods. Where do they get called at? Record texture transition. I got it. Okay. So this is a public thing we have to call when we're ready to do that. Okay. But I got these done. So they've got a getter for file name and for image view. So I can do that. Let's do getters for file name and image view. All right. And then we record copy buffer. Why did they put the privates for the public? I mean, on the one hand, I get it, but on the other hand, that's a little bit annoying. I tend to like, it's just the way my brain works. I tend to like to put, when you have a public method that calls a lot of private methods, I tend to like to put the public method above the private methods, and then that way it's a little bit easier to, like if you're looking at the public method, it's a lot easier to follow where the other private methods are. I mean, granted, I'm in an IDE, you just control click and it takes you there, but you know, it's just kind of it's nice to be able to sort of scan down with your eyes and see, oh, okay, here's the private things that this calls. It's not always possible because a lot of times you have to reuse private methods, and you know, other like multiple public methods will reuse the same thing, but whenever it's feasible, I tend to try to do it that way, just kind of as a code cleanliness kind of thing. You know, just to make it a little bit easier to grok. I guess the other problem here, I guess the other thing I need to ask myself is, do I want to move these? Yeah, I kind of want to move these record copy buffer and stuff to the static methods. Yeah. I sort of want to do that. Although, where's barrier coming from? Oh, it's made in there. Okay. And all of these are local variables, so that actually lends itself well to it. This one, though, takes width and height and image, so I'll just have to add those to the parameters. See what I can come up with here. Yeah, so I'm going to put those in. So we're doing record copy buffer. Why does that take... Oh, it passes the memory stack onto this colic. Okay. I was like, why doesn't it even take that memory stack? But there it is there. All right, so record copy buffer. So we want utils and Structure utils. There we go. What does this return? Nothing. None of them return anything, so I wonder. Record copy buffer, record image transition. This is fine. Wait, VK buffer image copy. Yeah, okay, that's not something they created. All right. Command buffer, Vulkan buffer data. And I guess buffer offset, image height. There's a lot of things that are just plain set here. Alright, I'll just pass with height and image in. Wait, if I pass image in, doesn't that have the width and the height in it? Didn't I just set the width and the height to the image earlier? Or am I losing my mind here? Image. Yeah, it's in the image data. The width and the width and the height. Man, oh man, I hate that they rely so heavily on these like class things when they've already set it. So really, I just need to pass image in and just pull everything out of the image. So it's just Vulkan image. Okay, so wait, that's the wrong thing. That is the wrong thing. Where am I at here? Here we go. Changing the wrong damn thing here. Image. Okay, so then VK buffer image copy dot buffer. Equals VK buffer image copy calloc. One stack. Okay. This needs a name. What do they call it? Region? And then we're doing region. Oh, no. Being a goofball here. And what are they doing first? Buffer offset, buffer row length. Buffer image height. Zero, right? Yeah. Image sub resource. Okay. Image aspect color bit. Alright, so image. Sub resource. Aspect mask. Aspect color bit? Yeah. Nip level 0, base array layer 0. And layer count 1. Okay, and then, oops, we have more here. Image offset. And image extent, okay. Oops, 0. XYZ 0, right? And then image extent is width, height, depth 1. Okay. With height depth, and then VK command copy buffer to image. Okay. Let's try it again. VK CMD copy buffer. Copy buffer to image. Get VK. So command dot command buffer. For data, get buffer, image. Okay, so data, get buffer, image, get image ID, and VK image layout transfer DST optimal. Okay, VK14. Okay, image optimal. And then region. All right, so get buffer is not what it wants. It wants a long. Buffer data, get buffer. So that's really the ID. Yeah. Alright, and then public static void record image transition. Command buffer. We need image again. And MIP levels. I don't know if I put MIP levels in image, so I probably didn't. I'll have to pass that in. So image and MIP levels. So old layout, new layout. Okay. So command buffer. Vulkan image, and int levels. Okay, and then we have oh, let's see. Memory barrier. Okay, VK image memory barrier dot buffer. What is this? This is called barrier. One stack. Structure type. VK structure type image memory barrier. VK structure type image memory barrier. Okay. Then old layout, new layout. Source queue family index and destination queue family index are both VKQ family ignored. Okay, and then image is image ID. And then another sub-resource range. What is this? Aspect mask. VK image aspect color bit. Color bit, and then base MIP level is 0. What's the other thing? Hey, Ahmed. Welcome on in. Game doesn't have a name at all. I'm learning how to make an engine right now. So name is subject to change once I eventually get to a point of actually making a game. Right now, I'm just interested in learning. Oh, level count, MIP levels, then base array layer. Okay, so level count, and then what was the other one? Base array layer and layer count. Base array layer and layer counts was 1, right? Yes. Okay. All right. So what are they doing here? So we have that. So source stage, access mask, destination stage. So what does all that actually mean? Do they explain that over here? So their record texture transition, copy buffer, appropriate state. Reduce the loading time when dealing with several textures. Okay. What is that? So what does that do? Optional. Record copy buffer. It's just talking about the record copy buffer. Not talking about the other one. I guess it talks about it later. to an image. Okay, it doesn't really describe those things, at least not yet. Record texture transition is the public one. So he's got a VK utils image barrier, which it doesn't actually have in the source code, which is kind of annoying. So it looks like someone has updated this book a little bit. But they didn't update their source code for it. I wonder if there's is VK utils, I wonder if that's something they provide now. Or if that's a... So that's their thing. And then... Let's see what happens here. So VK... Yeah, no, I don't think that's... I think that's just their own Vulkan utils that they created. Probably just has this whole method in it. Let me see. So we're doing the source stage and source access mask. So how does he have it here? He's got old layouts. Old layout is undefined. And new layout is destination optimal. Else if old layout is destination optimal, new layout is read only. Huh. Yeah, I guess that's about the only way to really handle that. I was trying to see if I could make that code a little smaller or combine some things, but no, this is probably about as clean as it gets for that, for what it's trying to do. So then it's adding those to the barrier, to source access mask, and destination access mask. Okay. So source stage, source access mask. Okay. If old layouts equals image layout undefined and new layout equals layout optimal transfer destination optimal, is that what I said? Yeah. Okay. Source stage, pipeline stage, top of pipe bit. What was it again? VK pipeline stage, top of, okay, VK pipeline stage, top of pipe bit. I think the access mask was 0. Yeah. Destination stage is pipeline stage transfer bit. There's too many things to keep in my brain here. Pipeline stage transfer bit. Access transfer right bits. All right, and then else if old layout is image VK image layout transfer destination optimal. VK image layouts transfer DST optimal and new layouts. Okay, image layout shader read only. Read only optimal. Source stage is VK pipeline stage transfer bit. Access transfer write bits. Okay. And destination is fragment shader bit, access shader read bit. Okay, so destination stage. What was it? Oh, pipeline stage fragment shader bit. Fragment shader bits. Access shader read bit. Pipeline stage fragment shader bit. Access shader read bit. Okay. Otherwise, throw an exception. this. There we go. So we got that. And then we set these source and destination access masks. Wait, oh yeah, and then we use the stage down here. Okay. I was like, what do we set the other things for? Then BK command pipeline barrier. Pipeline barrier. Command, get command buffer. Source stage, destination stage. 0, null. Null and then barrier. Okay. All right. So that method's done then. Send back to our texture thing here. And we have record texture transition, which is a public method, takes a command buffer. Okay. Command buffer. Record texture transition. I knew it was something else. And if staging buffer does not equal null and not recorded transition. Recording transition for texture. Okay, file name. Recorded transition. True. Okay, try memory stack equals stack push. Record image transition. Just gotta record it twice to okay. To move it around into the shader. Okay, record image transition. First thing. What did I put here? Stack command buffer. And then it's VK image layout undefined. Image layout transfer, DST optional image. Optimal. I said optional, but optimal. Okay. Record copy buffer. Did I miss something here? Oh, image and MIP levels, right. Image MIP levels. So stack command the buffer and then the image. And this same call except different parameters. So okay, image layout. So take this DST optimal, put it here. Okay. So and then it's VK image layout shader read only optimal. Okay. Layout. There we go. And that's it. Okay. Just an else to say that this has already been done. Okay. All right, so that finishes out the texture class there, I would say. Although I'm not setting width and height. Yeah, because I'm not. I pull them off the image data, right? Yeah. Yeah, pull them off the image data, so we don't need that there. So those can go away. And yeah, we're good. We're good here. What's the next part? So then we're doing a texture cache, which makes sense. Multiple meshes share the same texture file, so we want to control that. Just look at using Godot and GDScript is not bad, and Born C has good tutorials on YouTube. He has so much made in testing with volume. Yeah, like I said, and I will look at Godot eventually, at some point in the future. But I really just doing this because I want to learn the ins and outs if I can. You know, I like knowing how the code works. Having the freedom to do the code the way I want to do it, per se. But yeah, no, I get it. And you know, I don't really have much of a game idea anyway, so this is kind of nice in that I can just sort of just have an engine and then just figure out from there what I want to do with it. once you're making tests as you go, you see stuff work, you change them. Oh yeah, no. I totally get you. I totally get you. Like when you have an idea and you just want to sort of iterate on it and see how it works and stuff. Yeah, absolutely. Like jump right into the engines and stuff. Yeah, no, I get it. And yeah, there is a lot of fun to be had there. Absolutely, absolutely. Um, but I'm also it. I know it looks like a lot, but I'm actually having fun looking through all this stuff too. The only thing I wish is that it was a little bit more um a little bit easier to read through and figure out and learn what's going on. But you know, once the code is written and I have something, I can start to play around with it and see how these things actually interact with one another. Just taking even blocks and testing, see the changes as you. Yeah, I know that in Godot you can. That was the one thing that really interested me about Godot is that the entire IDE that you use is written in Godot, so it can just basically run, like it can instantly update stuff in real time, so you can see the results and stuff. So, no, I don't know any Python, but you know, I imagine I could probably learn it relatively, relatively quickly. Um, it is one of the languages on my list to learn just for even for professional purposes, because there's a lot of websites now. There's a lot more websites now being written in Python. You know, so if I ever needed to fall back on something, if Java ever were to dry up, which I doubt, unless Oracle gets really rammy at some point, then Python was kind of my next one to look at. I guess C# too, but you're not really doing websites in C#. If you are, good luck. um, yeah, but yeah. No, it's all on my eventually get to list. I'm just having a lot of fun. Reinventing the wheel, essentially. So, but yeah, have a good night, Tech. I appreciate you dropping by. I noticed that the GE script is not hard to learn. It's all based on. Oh yeah. I mean, once you've got like one language under your belt, even if you only have it partially, most of the programming languages all share common groundwork. You know, they just have different restrictions put on them. Yeah. I mean, hell, the C# stuff is basically Java. It's just different package layout and stuff like that. And it has a little bit more syntactic sugar, but yeah. I was actually surprised at how much overlap there was. Microsoft was really ticked off about Visual J++ never taking off, and they were just like, well, we're just going to go do it anyway, but we're not going to call it anything related to Java at all. um, let's see. All right, so the next thing on the list is the texture cache, which makes sense. And it looks like it's probably going to be pretty straightforward. I can't imagine they'd make it that complicated. Let's see. Where would they put that at? Here it is, texture cache. Oh yeah, this is pretty straightforward. It looks like it's on ground or something like that. The player was touching ground, which makes sense. Yeah, yeah. It's just called for your AC on in the bedroom. Well, I'll tell you what, it was, I just looked at my, so I have a thermometer that's like an outdoor thermometer that, is part of my central air. And so it has a reading on my central air panel. And it was earlier today, it was 101, so it was a hot one today. Oh yeah, no, I get it. Yeah, I mean, it's just absolutely necessary to have an AC, at least for a little bit, especially if it gets really humid, because it's like we'd hit 138 at your work. Oh, God, that is just. Good googly moogly. that is too hot. Jeez Louise. It's like, at that point, you're practically drinking water every 5 minutes because you're losing it so fast. Right? I mean, you gotta be like standing in a puddle of sweat at some point. We had to open a 400-degree oven. Oh, God, yeah. Yeah. That's just... Yeah, I can't imagine. I mean, I'm not a fit person to begin with, so I can't imagine even attempting. Went through so much water, was nuts. I imagine. Like, that's the point where you pretty much take Gatorade with you or something like that, because you're going to be losing so much salt just from drinking so much water just to stay hydrated, that you kind of have to like go halvesies, like 3 regular waters into 1 Gatorade or something like that, Why you lose weight so easy? Oh yeah, definitely. That'll lose it. Gives it to you free or most. Oh yeah, you have to. I mean, they have to provide at least some basic accommodations. You know what I mean? Like, because that would be insane if you had to bring your own water. Coolers with ice and stored in it. Yeah. Mm-hmm. Yeah. Yeah, that's craziness. And I imagine you have to have some sort of, if you're working with ovens and stuff, you probably have some sort of protection on, right? So that makes it even hotter. Whether it's an apron or something like that. Ugh. Protection, what's that? All right, I take it back. Pants and shirt, okay. Just move fast. Got it. I understand. Don't stop the look. In my head, I just keep seeing that video online where some machine, I guess it was a welding machine or something, blew out and it just caught the whole place on fire. Like it just absolutely exploded. Stuff looking out fast and get the chain hooked up with one step in the oven and out. Just yeah. I get it. Yeah, geez Louise. Oof. Yeah, my grandfather did some kind of, I think he worked at an ironworks. I don't actually know what it was. He worked with, I think, iron smelting works or something like that. And I think he was a safety guy, safety inspector. I don't even remember what he did, but they had an accident one day where an oven blew out on him, and he got pretty singed from it. Survived, thankfully. I don't know if all the guys that were around the oven survived, but I know he did. But yeah, oof, crazy stuff. Leave a footprint on the floor. Shoe melts a bit each time. Oof, yeah. You did that, lost your thumb at one 30 years ago. Oof. All right. Okay. Okay, Tech. Well, you have a good night. And I'll see you when I see you. All right. Have a good night. Cool. 4 a.m. Oof. I'll be asleep. But I will catch you in the morning if you're still, because you usually go pretty long. So I'll catch you when I catch you in the morning. Do a 20-hour stream. Yeah, that's mad respect to you, because I can barely do a 3-hour stream before I'm like, okay, time to sleep. Because I just can't. My brain cannot handle it for that long. My body can't handle it for that long. Honestly, I have to get up and walk around a lot. My legs being the way they are. Okay. Well, when you're streaming tomorrow, I'll pop in when I get up. And yeah, cool beans. Okay, I will. Later. So the texture cache, I could probably just do this texture cache like right now. Like that's the next thing they want you to do, right? I could probably knock this out. Texture map. What are they? So they're mapping the string to, okay, to the ID. Or to the, they're probably mapping it to the file name. That's what, I imagine that's what they're doing. So where's their texture cache at? Texture path. Get default texture path. texture map get path. Oh, okay. Engine properties get default texture path. If texture path is null or empty, then get it from there. Okay. Why would you even do that? Like this part here doesn't make sense to me because then you're going to I mean this is just going to fail, right? You're just going to get that's not going to be there. Yeah, that's weird. I don't know why they're doing this. Just give you it should be just by the file name. Or by the full path to the file. Right? I mean, and if they don't pass a full path to the file, then just fail. Like why would you try to do that? That doesn't make any sense. Get as lists. Get a list of textures. Get position. Why? They don't even call get position. It has no usages. Why is this even here? If texture path does not equal null. Get index of texture path. Why would you need the position? That doesn't make any sense to me. Like the get texture makes sense, even though they're not calling it. But honestly, even that is not really necessary because when you call create texture, if it's already cached, it'll just give you that back. So really, none of these methods make any sense to have right now. So it's just create texture and then the cleanup. Indexed linked hash. Why are they doing an indexed linked hash map? Oh, they created a thing called indexed linked hash map? Why? Get index of. Extends linked hash map. Why? Why would you even need that? The reason for this structure is to be able to recover the texture by its path, like in a map, while maintaining the insertion order. Later on, we'll need to get the textures by the position they were loaded. Although by now, for now, we will be accessing by path. Later on, we'll need to get the textures by the position they were loaded. Why would you need to get the textures by the position they were loaded? I don't understand why that would matter. You get the textures by the position they were loaded. Okay. I mean, I guess if you're trying to I mean, if you're assuming the textures are being loaded from the model, maybe for animation purposes, they need to know the position they were loaded. You know what? We'll cross that bridge when we come to it. And actually, they haven't listed here as add texture, and not as create texture, which is what it is in the code. I'm seeing a lot of inconsistencies now. It's like up to this point, up to chapter 7, everything's been really consistent, and now chapter 8, all of a sudden, I'm seeing inconsistencies between the code that's listed on the chapter page and the actual code in their samples thing. So that's fun. Hopefully this just works. When we get to the end of this. So texture cache. Oh, actually, you know what? I could test that, right? I can do chapter 8 here. So what is it? What is main? Edit configurations. Chapter 7. Chapter 8. Yeah, that definitely runs. So, okay. I'll assume that everything is good then. I am not going to do an indexed linked hash map unless I absolutely need to do it. That's just... A linked hash map maintains the order. I don't know what else... don't know what else you'd need. And you can do an entry set on it, and the order is maintained. Like, I don't understand. All right, so we just need the texture map and basically the cleanup and the create texture. I mean, should be fairly straightforward. And actually, the texture cache can be in common here. All right, so where's my... There we go. So, where are we at? It's got Vulkan texture, so then, because I have didn't I have like a texture cache for these? I may have skipped it for those because it wasn't really that important at the time. Yeah, I probably skipped it there because I didn't really need it at the time. But under common here, let's do texture cache. New hash map. All right, I will say texture, create texture. So I don't want to have to cast it if I can help it. It's texture. Oh, see, it takes a device. Why did they take a device? Because they're creating a new texture and they need a device for that. Rather annoying. All right. I'll have to do. I don't need this then. I don't need to be generic. Actually, yeah, I do need it to be generic, right? Because I'm doing a... Yeah, so I think I'll keep it generic and then let's see. It's not gonna let me do that. Yeah, no, it wants a return type. You can't just do that. Oh wait, can I do object T? Would help to spell it right. Wait, can I do, wait. Oh, I can do that, yeah. I was like, I would think you would be able to, because it'll know what the type is at compile time. All right, and then public. Void cleanup. Oh, it's calling Vita cleanup. Wait. Oh, that'll work though because I have. It doesn't know here though. Yeah. All right. Go. All right, we'll see. So base texture cache. So then down here we'll do new Java class. Base texture cache. Vulkan texture. There we go. All right, so to clean up, we'll do that first. For each. Oh. I was like, wait, what's going on here? KV. Okay. Let's get that simple enough. Here we're saying device texture path. So I can't define create. Ah. God, I hate the way they have this laid out. Because you have to have freaking device everywhere. And it just makes everything just fugly. If I get Hmm. Well, yeah, I mean, I guess you could have multiple devices. But we're only getting it by the path. Yeah, but you still could have multiple devices. Damn it. There's almost no reason to have a base texture cache now because... God damn it. Alright. Get rid of base texture cache. Delete. Okay. So we have that. So then here is going to be logical device. Full path and format. What are we doing here? String path. I'm not doing any of that crap. So texture. We have to get path. Okay. So we can do that. Compute if absent. It's not. Equals cache that. So I want to use the put if absent. Nah, because we'll have to have like equals and stuff on there, so we'll just do get full path file if pictures null. New device file name, image format. I mean, that's basically what you're doing there. Put doesn't return it, does it? Oh, the previous value associated with key or null if there was no mapping for key. Okay. Okay, got it. Would I know how to program in ray tracing or path tracing? The games like Ghost of Tsushima, for example. I don't know right now. I'm hoping to learn that as I go. I don't know. I know the basic idea of ray tracing, but I don't know the ins and outs of like how to implement it, or don't really know much of the math behind it either. But yeah, there is a the Duke Nukem 3D source code is, I think, out on GitHub. And that is the build engine, and I believe the build engine used ray tracing for that game, much like Wolfenstein 3D used it. And there were things like you shoot out rays, and then depending on how many polygons it crosses, like if it crosses an odd number or an even number, you do one thing versus another thing. But I don't know much beyond that. And the ray tracing nowadays is used, I think, mostly for reflections and stuff. It may be used a little bit in lighting, for like God rays and stuff like that, I think. But if I'm not mistaken, it's mostly used for reflections and reflective surfaces, because it can then, it traces a ray back to the camera to see how it would, what it would actually reflect based on the angle of the camera. But I don't know. But like I said, I don't know the specifics of how any of that works. I'm hoping to learn that as I go here. Unfortunately, their ray tracing chapter is empty right now in this book that I'm using. But when I get to that point, I can probably see what the general gist is out on the interwebs. Because I got a lot of things like this book does cover things like physicality based rendering and stuff, which is basically making materials shine differently, based on lighting conditions and all that stuff. So that's like part of the way there. And then like HDR and stuff like that, I don't know anything about. So yeah, I'm going to be learning a lot of stuff, hopefully, as we go. So what did I do here? So create texture, and then return it. Yes. So that's all we really need for the texture cache right now. I'll still learn and growing. Yeah, there's a lot of, that's kind of the reason, one of the reasons why I wanted to dig in and try to do my own engine. Because there's a lot of concepts that as gamers we just take for granted, that you just see in an options menu and you're just like, well, I guess I'll tweak this or I guess I'll tweak that, but I don't really know what it does. And it would be nice if during the course of this I can learn firsthand what a lot of those things do. Have like a better idea of it. So like when I'm playing a game and I want to tweak it for performance, I actually have some insight into it, into what's going on under the covers and stuff. So yeah, we'll see. We'll see. I mean, that's the hope. Okay. So we have our texture cache. And I think what's the next thing that they go on to? Models and materials. Okay. So we're going to be updating the Vulkan mesh and Vulkan material and the models cache. Okay. That makes sense. All right. That might be a good stopping point for tonight because my brain is starting to turn to mush. Let me go and get rid of all these. I don't think I need those hanging around. And let's go and commit some stuff out to the old GitHub. Oh, that got removed. Okay. So we're doing chapter 8 starting. So we need moved, deleted. I don't know why that one is. Oh, because I got rid of it, I guess. Alright. Cool. Anyway, and push. Alright. Awesome. I think that'll do it for me for tonight, my friends, but I'll be back tomorrow afternoon. And we'll pick up where we left off here and do some more coding. And then tomorrow night, if I'm up to it, I should be up to it. We'll go and we'll play some more Planet Crafter, and then same for Sunday nights. Just some Planet Crafter on Sunday night. And then next week, Monday, well, basically until we finish the game, we're gonna finish RoboCop Unfinished Business. So that'll probably be Monday, at least Monday and Tuesday, I would imagine, probably into Wednesday. But I definitely want to finish that. And then we'll see what else is after that. What I probably revisit something, or at least maybe I'll go back and do some Torchlight 1 and try to start to get to the end of that. Maybe, I don't know. We'll see whatever I'm in the mood for. Yeah, that's about the half of it right now, my friends. Thank you so much, everyone, for watching. If you happen to run across this on the YouTubes and you have a like and or a subscribe that you can toss my way, that would be really swell and awesome. It helps out tremendously, and I appreciate it greatly. Um, Otherwise, thank you so much for watching. I hope everyone has an excellent morning, afternoon, or evening, depending on what it is for you, and hope to see you back here again in the future for some more stuff, whatever happens to suit your fancy. Until then, see you, bye.
Kokainom.